This question is very simple. Let's walk through it together. We are given this to find the value of k. These are the options that we're given. So the question is rewritten here. Root 28 plus root 112 minus root k equals to root 175. Since we are looking for k, we want to make root k subject of formula by taking it over across the equal to sign and taking root 175 to the left. So by collecting like terms, we have that root 28 plus root 112 minus root 175 when it crosses equal to root k. Root k become positive when the negative crosses the equal to sign. So we've successfully made root k subject of formula. At this point, we can now simplify the left-hand side and equate it to k. To simplify the left-hand side, since they are all surds, we are going to need perfect squares to do it. So I'm just going to put down the list of some perfect squares here, which we will use as factors of the numbers in the square root. Because to simplify a surd, we need to break down the surd into a product of a perfect square and a non-perfect square. So let's look at root 28. These are perfect squares, so let's start with 4. If 4 divides 28, what do we have? We have 7. So 4 is a perfect square, while 7 is not a perfect square. So root 28 can be broken down into root 4 times 7, where 4 is a perfect square. So we need to have at least one perfect square as a product. Let's try root 112. If 4 divides 112, we obtain 28. Instead of using 4, since 28 can still be broken down, let's skip 4 and go to the next one. The next perfect square is 9. Can 9 divide 112? No, it has remainder. We skip 9 and we go to 16. Can 16 divide 112? Yes. If 16 divides 112, you obtain 7. So 112 can be broken down into, remember this plus 16 times 7, all in a square root. Then minus, let's break down 175. Since 175 is bigger than 112, instead of going back to the beginning, let's try 16. 16 divide 175 cannot. Let's try the next one, 25. 25 divided by 1 divides 175 to give 7. So this becomes minus root 25 times 7, and everything is equal to root k. So the problem is now simplified. The next step, we take the square root of each of the perfect square multiplied by the surd root 7. And that becomes the square root of 4 is 2 times root 7. Plus the square root of 16 is 4 times root 7. Minus the square root of 25 is 5 times root 7. Everything equals to root k. Now the left hand sides are similar surds. Similar surds because the irrational parts are the same, root 7, and root 7. So we can add and subtract them. 2 root 7 plus 4 root 7 gives us 6 root 7. 6 root 7 minus 5 root 7 gives us root 7. So root 7 is equals to root k. It's just like saying 2x plus 4x gives us 6x. 6x minus 5x will give us x, where we are replacing root 7 by x. So that is how you operate surd in addition and subtraction mode. If root 7 is equals to root k, to obtain the value of k, we need to square both sides to cancel out the square root. So if we square both sides, we have root 7 square equals to root k square. The square will cancel out the square root and we will be left with 7. The square will cancel out the square root and we will be left with k. Therefore, k will be equal to 7. And that means the correct answer is option B, 7. It is very simple, and if you understood it, then try this. Find n if root 48 over 10 plus root 3 over 10 is equals to n root 3. Please put your answer in the comment section. Please encourage us by sharing this video to others. Like, comment. I will be in the comment section waiting for you. Thank you for watching and see you in the next video.